We're going to look at the chain rule. So to find the derivative of composite functions, you have to do something just a little bit different. So if f and g are differentiable, then the composite function, f of g of x, and I'll just call that h of x, as we could say that h prime is f prime of g of x times g prime of x, which I always just say derivative of the outside times derivative of the inside. So sometimes we got to figure out which function's the inside function, which function's the outside function. And we can use a u substitution, which I'll show you on some of these. So first one says, find the derivative of f of x equals 5x plus 3 quantity squared with and without the chain rule. So without chain rule, we'll have to expand this. We will have to take that 5x plus 3 and multiply it by itself. So you can do, what's it called? FOIL, that first, outer, inner, last, or the box method. So f of x is going to become 25x squared. And then I'll have 15x plus 15x. So that's going to give me 30x. And 3 times 3 is 9. So then when I do the derivative, I can just use my power rules here and make that 50x plus 30. All right. Now with the chain rule, right, I can see this function as sum quantity squared. So we have an inside function that happens to be 5x plus 3. So we do the derivative of the outside. So I'm going to use a u sub here. I'm going to say, hey, u is 5x plus 3. And then I'm going to take a derivative here. So u prime is 5. And if I rewrite my function in terms of u, this will be, instead of f of x, it'll be f of u. And that's u squared. All right. So we can take the derivative here. F prime of u is 2u, right? And then we can substitute back in our chain rule part here. So we've got, substitute back in u, so 2 times 5x plus 3. But then it's also times that u prime, which is 5. And then I can FOIL all of this out. So let's just make this 10. So 10 times 5x plus 3, that's going to give me 50x plus 30, which, if you notice, is the same either way. Arguably, when it's a quantity squared, it's a little faster to do it without the chain rule. But in something like this next one, 4 minus x squared quantity cubed, the chain rule might be easier. So I can do a u substitution again, or I can visualize that, hey, it's some quantity cubed. So if I want to do the derivative, I do the derivative of the outside, so that quantity cubed. So 3 times the quantity and subtract 1 from the power. That quantity is going to stay the same as the original. And then I just need to multiply it by the derivative of the inside, which is going to be negative 2x. And then I can clean it up here and say, hey, that's negative 6x times 4 minus x squared squared. That seems a lot easier than cubing all of that out to then use just the power rule. All right, look at some more here. I might want to rewrite this and use just a fractional exponent. So instead of that square root there, I'm going to make that x squared minus 1. It's always power over root. So it's to the third power, and then that's a square root. So I could say the derivative of the outside is 3/2 quantity, and then subtracting 1 from the power, and then I have to multiply it by the derivative of the inside, which is going to give me 2x. And then I will clean this up a little further. 3 halves times 2x is actually just 3x. And then that's x squared minus 1 to the 1/2. We can throw back in the radical, or we can leave it. I'm going to leave it because I've already written it this way. All right. I can do one of two things. I can use quotient rule, or I could rewrite this as -7 times 2x minus 3 to the -2 and do chain rule. And that's what I think I'm going to do here. So derivative of the outside is going to be -7 times -2, which is 14, times 2x minus 3, subtract 1 from the power, and then times the derivative of the inside, which is 2. And then we can clean it up here one more step and do 14 times 2. So 28 times 2x minus 3 to the -3. And we can drop it back down to the denominator or leave it. All right, I'm going to do another one with I'm going to use the U sub notation for this, just so we can get some practice with that. So U is 5 minus 4x squared. U prime is -8x. If I turn this in terms of U, yeah, I'll keep the variable. I don't know. Y of U is U to the 2/3. So when I do the derivative, I do 2/3 U to the -1/3 times U prime and resubstitute back my original things. So Y prime is 2/3 times 5 minus 4x squared to the -1/3 times U prime, which was -8x. And I'll clean up one last step here and make that a -16/3 x times 5 minus 4x squared to the -1/3. All right. All right, I'm going to rewrite this, and I'm going to use quotient rule since we now have that in our skill set as well. I'm going to make that 6x plus 3 to the 1/3. And I'm going to use that quotient rule. So low d high minus high d low all over low low. So y prime is low times d high minus high d low. I'm going to use the chain rule here. So 1/3, 6x plus 3 to the -2/3 times derivative of the inside, which is 6, all over low low. And then I'll just do some cleaning up here. So that first quantity is going to be gone. So I'm going to clean up this one here. Negative times negative will be positive. 2/3 times 6 is going to be what? 2 times 6 is 12. 12 divided by 3 is 4. So 4 times 6x plus 3 to the -2/3 over 6x plus 3. And then 1/3 times 2, we use the power rule of exponents. There is going to be 2/3. And then I'd probably clean it up one last step, just because those quantities of 6x plus 3, I think, can be combined a little nicer. I'm just going to drop that -2/3 to the bottom. So I'll have 4 over 6x plus 3 quantity to the, and when I drop that down to the bottom, we can add those exponents. So 2/3 plus 2/3 is 4/3. And there we have that. All right, let's keep it going there. Oh my goodness, I see a typo. It's supposed to be parentheses going the other way. It's okay. Alright, so we have g prime of x here. You know what? Let's do a u sub. So u is 6x squared plus 7x. So u prime is 12x plus 7. I'm going to rewrite this in terms of u. So g of u is u to the fourth. So then when I do g prime of u, I can do 4u to the third, and I have to times it by u prime. And back in terms of my original variable, I can just resubstitute in some quantities. So u was 6x squared plus 7x. I'll have that whole quantity cubed. And then times u prime, which was 12x plus 7. I think it's okay to leave it like that. If you want to distribute that 4 into that quantity at the end, we could say that g prime of x is 6x squared plus 7x cubed times 48x plus 28. Either one is fine. Alright, u is 4t squared minus 3t plus 2. U prime is going to be 8t minus 3. G of u is u to the negative 2. So g prime of u is going to be negative 2 u to the negative 3 times u prime, to give us a final g prime of t is negative 2 times 4t squared minus 3t plus 2 to the negative 3 times 8t minus 3. And again, we can leave it like that, or we can make it g prime of t is 4t squared minus 3t plus 2 to the negative 3 times negative 16t plus 6. Right, either one is fine. All right, we have a product rule and a chain rule here. So, okay. I'm going to do off to the side the chain rule piece. So u is going to be 5x squared minus 1. U prime is 10x. Oh, that should be 5x squared minus x. And then the derivative is 10x minus 1, I add. So if I do a substitution, or let's just put that derivative together. I'm going to do a box here. And then I'll put a box around this final derivative. So the outside times the derivative of the inside. And then let's clean that up and make that a 5x squared minus x to the negative 1/2 times 5x minus 1/2. I'm going to box that in because that's the derivative of that right piece. Because for product rule, we're going to do left times derivative of the right, which is I just found that. So left d right plus right d left. All right. And then let's see, what can we clean up? Deciding if I want to take out any kind of GCF here. Would it benefit us to do that? I don't know. Let's try it. So both quantities have at least an x, and they have at least a 5x squared minus x to the negative 1/2. And so if I factor that out, I'm left with x. This quantity would be 1 and 5x minus 1/2, which I could distribute that x. And then let's see, I'm left with a 2. And then when I divide that quantity out, sorry, I was losing my train of thought there. When we divide out, we're subtracting the exponent, so 1/2 minus a negative 1/2 is really 1. And then I wonder if I can combine any like terms if I were to distribute. So let's see, that's 5x squared minus 1/2 x plus 10x squared minus 2x. And I think I have some like terms I can combine. And then I can give a final answer. And maybe I should put it above. Hang on, 5x squared minus 1/2 x plus 10x squared minus 2x. So I could really say x times 5x squared minus x to the negative 1/2, all times 15x squared, and then these two can combine. Negative 2.5. What is that as a fraction? 5/2 x. I don't know. Would it be nicer if I threw that x back in? I don't know. But there's another version of it. Another simplification, if you will. All right, another quotient rule with, interesting, a chain within a chain. Or, yeah. Okay, I'm just going to do the derivative and do it piece by piece. So low d high, low, times derivative of the top, which is a chain rule. So 3 times 2x plus 1 squared times 2. Low d high minus high times d low. So 2x squared plus 2x plus 1, and then times the derivative of the inside, so 2x plus 2. All over low, low, which I am going to go ahead and simplify, and it's going to be 2 raised to the 2. So that's going to be a 4. And let's see what we can simplify here. So I have x squared plus 2x plus 1 squared times 6 times 2x plus 1 squared minus, let's go ahead and distribute that in. So 2x plus 1 cubed times x squared plus 2x plus 1 times 4x plus 4 all over x squared plus 2x plus 1 to the 4th. Well, I notice that I have an x squared plus 2x plus 1, x squared plus 2x plus 1, and x squared plus 2x plus 1 that I can simplify further out. So I'm left with one quantity here. And then left with 2x plus 1 cubed times 4x plus 4. All over x squared plus 2x plus 1 cubed. I don't know if it would make it nicer to pull out yet another GCF of 2x plus 1. I don't think that would. I guess I could also pull out a GCF of 2. But I think this is good enough because I don't think any other quantities are going to cancel out. So here's where I argue what is more simple, a GCF factored version or something like this. So I'm going to leave it. All right, I'm going to rewrite this as 1 minus 8x to the 1/3 to then do chain rule. So derivative of the outside, which is 1/3, 1 minus 8x to the negative 2/3 times the derivative of the inside, which is negative 8. And then combining some terms, we'll do a negative 8/3 times 1 minus 8x to the negative 2/3. Alrighty, another product rule here. So left times the derivative of the right, which is a chain rule. So 4 times negative 4x squared minus 3 to the 3rd times the derivative of the inside, which is going to be negative 8x. So that's left d right plus right, and then d left. And let's see what we can simplify here. We have, let's do a constant out front. So negative 32x times 3x cubed plus 1 times negative 4x squared minus 3 cubed plus 9x squared times negative 4x squared minus 3 to the 4th. Now, I'm going to see if things simplify down. I don't know that they really will. Like, I don't know if this version here looks more simple than the version I'm about to show you. But, let's see. I could factor out a GCF of negative x. And then I could also take a negative 4x squared minus 3 to the 3rd. So if I factor all that out, that's going to leave me with 32 times 3x cubed plus 1 in that first set. And then the second one is going to be a 9x and negative 4x squared minus 3. So I could do a little combining here. Let's see, 32 times 3 is 96, and 96x cubed plus 32 minus 36x cubed minus 27x. So I could combine some more like terms and make this negative x times negative 4x squared minus 3 cubed. And let's see, 96 minus 36 is what, 60? 60x cubed minus 27x plus 32. And I don't even want to look to see if that factors any further, or if there's a GCF between 60, 27, and 32. But, all right, we could argue which one looks simpler. I guess the bottom looks a little simpler. Takes a couple extra steps, but could be one or the other there. And I think, yeah, that is all I have for chain rules. If you have any questions, let me know.